We can solve equations using the multiplicative inverse, which, as a reminder, the definition of multiplicative inverse, it's the same as reciprocal, also known as reciprocal. So if you multiply a number by its multiplicative inverse or the reciprocal, the answer is always 1. So in the example that I have here, 2/3 times something equals 1. Well, I know it's going to have to be a fraction, and I remember reciprocal from earlier in the year when we learned how to divide fractions. The reciprocal of 2/3 would be 3/2. How do I know this equals 1? There's a couple of different ways. 2 times 3 is 6, and on the bottom I have 3 times 2, which is also 6, and 6 times 6 equals 1. The other way we learned how to do this was to remember that if there's something on the top that is also on the bottom, we can cancel those things out when they're multiplied together for this same reason. What is 2/2? Well, 2/2 is 1. So when I cross out a 2 on the top and a 2 on the bottom, what I've really done is I've divided by 1, which doesn't change my answer. So we're going to go ahead and solve a problem that looks like this. You guys have seen these before in some problems we did earlier. And I'm going to multiply by the reciprocal, which in this case will be 6/5. And the reason I choose 6/5 is because of that definition. I know that this is going to turn into a big 1. 6 times 5 is 30. 5 times 6 is 30. And 30/30 is 1. So this whole thing turns into a coefficient of 1. I have 1y. But you guys know I won't write 1y, I'll just write y because I'm lazy. And what I do on one side I must do to the other. So since I multiplied by 6/5 on that side, I have to multiply by 6/5 on this side. And I'm going to go ahead and turn this 40 into a fraction by placing a 1 underneath it. And now I can multiply straight across if I want to. 40 times 6 is 240, and the denominator 5 times 1 is 5, and then I could do that division. Now, if you remember, I actually taught a different way to do this, which uses what we just talked about on that last page. I'm allowed to rewrite numbers as a product. So if I cross out 40, I can write that as a product of 5 times 8. And why would I want to do that? Because a 5 on the top and a 5 on the bottom cancel each other out. What is 5/5? It's 1. So really all I've done is I've divided by 1, which won't change my answer. So now all that's left is 8 times 6, which is 48. So my answer is y equals 48. If I did this division, 240 divided by 5, I would come up with this same answer. You may choose to do either way, whichever is easiest for you. Now underneath this square, I have another problem that's pretty similar to what we just saw. It has 5/6 y, and it has equals 40. The only difference is this plus 20. So in that last problem, I only had one step, which was to multiply, and I had to multiply by 6/5. This is a two-step equation, which you guys are really good at doing. I start by circling my variable with its coefficient. The coefficient is 5/6. And then I have to deal with this plus 20. What is the inverse of plus 20, or the opposite? It is minus 20. What I do on one side, I must do to the other. That's why that balance line is there, reminding me that I have to do the same thing on both sides. This becomes 0. It's called a zero pair. And I've got 5/6 y equals 40 take away 20 is 20. Now this problem looks a lot like this problem over here did, and I'm going to solve by using the multiplicative inverse. That's what this lesson was about. So I'm going to multiply by 6/5, because that'll give me 30/30, which is 1. What I do on one side, I must do to the other. So I'm going to multiply by 6/5 on this side. I know that this turns into a big coefficient of 1, but I won't write 1y, I'm just going to write y. And then I'm going to finish this problem over here. Now I'm going to do this a different way than I did on that last one. Instead of turning this into a fraction with a 1 underneath it, I'm going to think about it like this. 20 divided by 5 is 4. And I've still got to times by 6. So I think my answer in my head, 4 times 6 is 24. I think the answer is going to be 24. So I want to offer that for those of you who can do that kind of math in your head. If not, here's a different way to do it. Like we just did, I'm going to turn this into a fraction. And I'm going to rewrite 20 as a product. I'm going to use 4 times 5 because now there's a 5 on the top and bottom. I can cancel out for this same reason over here. And 4 times 6 is 24. These are 2 problems I would like you to try. You have them on your note page. Please bring them to class completed tomorrow. And here's a quick review on multiplying fractions by whole numbers. We've already seen this in this lesson, so I'm just going to do the first one of these. If I have the number 4/5 and I would like to multiply that by a whole number, let's say I want to multiply it by 12. I can turn that into a fraction by doing this, and then multiplying straight across. 4 times 12 is 48. And 5 times 1 is 5, and then I could go ahead and I could simplify this if I needed to. If I'm using a different number, like perhaps the number 20, well, let's not use 20, let's use 25. If I'm multiplying by the number 25, I can write 25 over 1, and then I can use that same idea to turn this into a product, 5 times 5, and the reason I do that is so I can eliminate something from the top and bottom, and that's going to give me 4 times 5, which is 20. But I do want to show that you can do this in your head sometimes when the problems are like that. For example, if I wanted to multiply this by, let's say, 32. Well, I'm going to look at 32 and 8, and I know that 32 divided by 8 is 4. And then I would have to do 4 times 5, which is 20. I think that this answer is going to be 20. And I'll check by putting my 1 underneath. And I'll change this 32 into a product. I'll use 4 times 8 because I see that 8 on the bottom there. And 8 over 8 is 1. That's why I'm allowed to cross them out on top and bottom. 5 times 4 is 20. I'd like you to do this last one in your head if you can. I want you to do 1/3 times 39. Now here are a couple of problems that have lots of fractions, and you can see I have my page divided in 2, which means I'm going to be solving the same problem 2 different ways. You will choose whichever way makes more sense to you. Both methods work. So I'm going to start with this problem on the left the way that I always do, by putting in my balance line and by circling my variable c, which with its coefficient 2/3. And now I have to get rid of a plus 4/3. The inverse of plus 4/3 is minus 4/3. And what I do on one side I must do to the other. This will become a 0 pair. They cancel out, they add up to 0. And what I am left with is 2/3 c equals, let's see, 9 take away 4 is 5, and the denominator remains the same. My final step will be to multiply by the multiplicative inverse, or the reciprocal, 3/2. What I do on one side I must do to the other. And I did that because 3 times 2 is 6, 2 times 3 is 6, 6/6 is 1. This turns into that big coefficient of 1. Instead of writing 1c, I'll just write c. And I get to finish this problem by multiplying straight across. 5 times 3 is 15. Over 3 times 2 is 6. This answer is not good enough. It needs to be simplified. So I would divide the top and bottom by 3, or what would have been easier at the very beginning. There's a 3 on the top and a 3 on the bottom. That leaves me with 5 over 2. So C equals 5 over 2. I want to show a different way to do this that we haven't seen before, and it's called clearing the fractions. And so what we're going to do is we're actually going to multiply this whole side by 3. And since I multiplied that side by 3, I have to multiply this side by 3. And I want you to watch what happens here, why I chose 3 and what's going to happen. So I have to distribute 3 times 2 over 3. Well, if I turn this into a fraction, 3 over 1, let's see. 3 times 2 is 6, and 1 times 3 is 3. So now I've got 6 thirds. See, well, what is 6 divided by 3? It's 2. I've got 2c. Now I've got to distribute this 3 over here to this other fraction. 3 times 4 is 12. Oops, let me write that up here. And 1 times 3 is 3. And what is 12 over 3? 12 over 3 is 4. Look at what I started with, and look at what I have now. I started with 2 thirds C, and now I just have a 2. I started with 4 thirds, and now I just have a 4. Because when I multiplied by 3, those 3's, there was 1 on the top and 1 on the bottom, they canceled each other out. So look what's going to happen over here on this side. Well, that 3 on the top is going to cancel with that 3 on the bottom, and it's just going to leave me with 9. Now I have a really easy to solve 2-step equation. I'd like you to go ahead and finish solving this. The answer is going to be 5 over 2, but I want you to prove it. And here's one final example of clearing the fractions. Now these two do not have the same denominator like in that first problem. This would have a denominator of 1. I'll go ahead and do that over here. On this side, I want you to solve it the way that we've always solved, where we would circle the variable with its coefficient, and you're going to begin by subtracting 2/5 from both sides. And what you'll notice, because these don't have the same denominators, is you're going to have to do some work with fractions. I do want you to solve this whole problem. I'm not going to finish it. Right now it looks like this, 3x equals, and then you'll have to do some work with the fractions there, and then finish by dividing both sides by 3. On this side, I want to do what I just did on that last problem, and I'm going to multiply both sides by something, and I'm going to choose 10, because when I look at the denominators, 10 would be the least common multiple. 5 goes into 10, 1 goes into 10, 10 goes into 10. So what's going to happen on this side? Well, what would happen? There's a 10 on the top and the bottom, they cancel out, so all that's left on this side is 1. That's a much easier number to work with than that fraction. Now let's go ahead and let's distribute this 10. It is a fraction if I write it like this. And what's going to happen here? I'm going to try and do some of this in my head. 10 times 2 is 20. 1 times 5 is 5. So I'm going to have 20 over 5. 20 divided by 5 is 4. And on this one, 10 times 3 is 30. And on the bottom, 1 times 1 is 1. Well, 30 over 1, that's just 30. 30x. I have cleared the fractions. There are no fractions left in this problem. This would be really easy for me now to go back, circle my variable and its coefficient, subtract 4 on both sides, and just go ahead and finish solving this problem. I need you to finish both sides of this. Your answers should match. And here's one final you try. I would like you to solve them both ways. Whichever method you don't like as much, I would like you to do that first on this side. And then I would like you to check using the other methods. So one of these you'll solve the way we've always solved, with just adding and subtracting the fractions, multiplying by the inverse. And on one of these you'll solve using that clearing method we just saw.